Today we are going to discuss about coefficient of multiple determination or R square. What is the basic interpretation of R square? At first I want to tell it. Before going into the part of numerical, R square explains that if there is a variable or if there is a equation, suppose y equals to 2 plus 5x, then R square, the value of R square tells us that how much variation of y can be explained by x. That means if value of R square is 80%, it means that 80% variation of y can be explained by x. That means 80% variation of y is happening due to x or because of x, and the remaining 20% variation or change in y is happening due to some other factors which are not included in this model or equation. So this is the basic interpretation of R square. Now R square is also known as coefficient of determination or multiple determination. So R square can be explained as the ratio of explained sum of square and total sum of square. What is explained sum of square? Explained sum of square is nothing but summation of y hat minus y bar whole square. Here this y hat is nothing but it is the regression line or equation of the regression line. Y hat can be further written or explained as equals to alpha hat plus beta hat x. So this is basically the equation of y hat, and this y bar is nothing but the mean value. Now this difference y hat minus y bar can be further written into small y hat square. Here this y bar capital Y here this capital Y hat minus y bar can be written as small y cap square. Okay, now this formula can be further written into this form: b1 into summation small y into x1 plus b2 into summation y small y obviously into x2. What is this b1, what is this b2? We are going to explain it in the later part when we are going to the numericals. At first let me explain the TSS. Now TSS is nothing but summation capital Y minus y bar whole square. It is nothing but it can be further represented as summation small y square. So as I have said earlier, R square indicates the percentage of variation in the dependent variable y which is explained by the independent variable. If there are two independent variables, if there are two independent variables x1 and x2 in the model, and our model is just like suppose y equals to alpha plus beta x1 plus gamma x2. Here if I calculate the R square, then that R square is going to tell me that how much variation of the dependent variable y is explained by the independent variables x1 and x2. If there are more independent variables, then R square is going to tell us the variation of that also. If there are three independent variables in the model, that is x1, x2 and x3, then R square, the value of R square is going to tell me that how much variation of y can be explained by x1, x2 and x3. What is the limitation of R square? One of the major defects of the R square is that the value of R square increases in every addition of the independent variable. That means if you increase the independent variable, if you increase this x1, x2, I mean if you increase more and more independent variables in the model, suppose here there are only two independent variables in the model, but if I add more and more independent variables, suppose if I am adding alpha plus beta x1 plus gamma x2 plus suppose I am adding delta x3, the more I add independent variable, the more the value of R square will be. So basically it can be possible that the variables are not significant. x2 is not explaining y properly, or x3 is not a proper, or x3 is not giving the proper explanation of y. But still if we add x2 and x3, in the model, it will increase the value of r square. So that is a very huge shortcoming or limitation of r square. That's why we calculate the adjusted r square to deal with this problem. It is a modified version of r square, and it is adjusted for the independent variables that are irrelevant to the model. So in the case of adjusted r square, if you calculate the value of adjusted r square, if you increase the number of independent variables, suppose you are at first the model was y equals to alpha plus beta x1, now you have increased it by two more variables by adding two more variables, and now the model is y equals to alpha plus beta x1 plus gamma x2 plus delta x3. In this case, if x3 is not relevant and x3 is not explaining y properly, then the r square value will not increase. In case of adjusted r square, if the independent variable is not relevant, then by just adding the irrelevant variable, the value of r square will not increase. Okay, so what is the formula of adjusted r square? It is 1 minus r square into n minus 1 divided by n minus p minus 1. Here n is the sample size, p is the total number of independent variable in the model. Now adjusted r square can be further also written as 1 minus ESS by degrees of freedom minus TSS of degrees of freedom. Adjusted r square is always less than r square, obviously, and adjusted r square is equals to r square if r square equals to 1. Okay, r square equals to 1, it means that 100% of variation of y can be explained by x or independent variables. Only in that case adjusted r square and r square are equal. Now if I have to calculate the adjusted r square, so suppose we have some data given, the data of y, data of x1 and data of x2. Now at first there are two questions given here: multiple regression equation of y on x1 and x2. That means we have to actually calculate y equals to alpha plus beta x1 plus gamma x2. Here that is the equation that we have to calculate. Now x1, x2 and y, these are the values given here. This is basically y, x1 and x2 are nothing but the variables, but alpha, beta and gamma are the parameters. Okay, so we have to parameters or parametric constants. So we have to actually calculate this value of alpha, beta and gamma. Now how to calculate this? For this we have done some calculation here. Let me show that. Now we have the value of y. So from the value of y we have actually calculated small y. So how can we calculate small y? Small y can be calculated by subtracting the y values, by subtracting y bar, that is the mean of y, from the y values. So how can we calculate the value of y bar? I hope you all know that summation y divided by n is the formula of calculating y bar, and I am subtracting this 11 from each of the y values. In the same way I am also calculating the small x. Okay, so in the same way I am calculating the small x, and I am calculating the small x1 and small x2 also, and I am also calculating small y square, small x1 square, small x2 square. Okay, now we have to calculate small y into x1 and small y into x2. So these are the values that we have calculated, and these values will be required in the formation of the multiple regression equation. Now let me alter the page. Yes, so basically multiple regression equation of y on x1 and x2 can be written as y minus y1 equals to b y x1 x2 into x1 minus x1 bar plus b y x2 x1 plus into x2 minus x2 bar. Now how can we calculate this value of b y x1 x2? This is nothing but summation y x1 into summation x2 square minus summation y x2 into summation x1 x2 divided by summation x1 square into summation x2 square minus summation x1 x2 whole square. By just putting the values in the place of the, we have calculated it in the table, right? Just putting the values from the table, we can calculate the value of by x1 x2. Similarly, in that fashion we can also calculate by x2 x1, and by calculating that we will just put the values as it is in the equation. This value is being calculated, this value is being calculated, this is known from table, this is known from table. So I have, and this is also calculated from the table. So we are just putting the values as it is. Okay, and now if we just do little bit subtraction and multiplication, then we can actually get the regression equation, multiple regression equation of y on x1 and x2. Now how to calculate r square from this? Basically r square is nothing but ess by tss. Ess is nothing but summation y hat minus y bar whole square. Ess can be further also written as by x1 x2 into summation y x1 plus b y x2 x1 into summation y x2. Here y and x both are basically small y and small x. What is the difference between small y and small x? Small y is nothing but capital Y minus y bar. Okay, and what is the difference between small x and capital X? Capital X is nothing but small x is nothing but capital X minus x bar. Okay, so here we know this value, right? We know this value, we know this value also, we know this value also. All of these are obtained from the table, so we can find out ESS. Similar way we can find out TSS also. TSS is nothing but summation small y square. Summation small y square was calculated in the table already, so it was 90. And if we calculate the r square now, r square is 0.96. What is the interpretation of it? It means that if you multiply this number by 100, then it will show you 96%. Basically we are taking the percentage of the value of r square. So it means that 96.76% variation of the dependent variable y can be explained by the independent variables x1 and x2. That means 96.76% variation of the dependent variable is happening due to x1 and x2, and the remaining 3.24% variation in y is happening due to some other factors which is not included in the model. Okay, and here we can also calculate the adjusted r square. For that we will require the value of r square, we will require the value of n, which is nothing but 6, we require the number of p is nothing but the number of independent variables in the model, and which is 2. So here the adjusted r square is 0.946. as you can see, adjusted r square is 94.6%, which is less than the value of r square. Okay, so the value of adjusted r square is 0.946%. It explains that 94.6% variation of the dependent variable can be explained by the independent variable x1 and x2. Okay, here another math is given. This is the homework. If you want to do it and post it in the comment, you may post the results in the comment.